in a large tabless cell than you have in the smaller cell with tabs. This is a big deal. So even though the cell is bigger, it actually has more power. The power to weight ratio is actually better than the smaller cell with tabs. This is, uh, again, like this is quite hard to do. So it's nobody's done it before.
What if everything you thought you knew about energy was wrong? For decades, we've relied on lithium, a resource that's driven our phones, cars, and even homes. But behind the convenience, a disaster is looming. Skyrocketing costs, environmental destruction, and catastrophic safety risks. Now, from the depths of Tesla's secret labs comes a technology so powerful.
We're building our own battery cells. We think the most advanced cell in the world here at Giga Texas. And we think over time this will probably be the biggest cell factory in the world.
It's set to shatter everything we've built. A new battery, forged from abundance, not scarcity, strength, not fragility. Is this the end of lithium's reign, or the dawn of an energy revolution? Prepare for the impossible. For decades, lithium has been the dominant power source for a variety of devices. It has quietly powered everything from mobile phones to electric cars and even homes. This lightweight metal, with its high energy density, seemed like the perfect solution for portable energy storage. However, as its usage grew, so did the complications associated with it. Rising costs, limited availability, environmental concerns, and safety risks have made lithium batteries a subject of increasing scrutiny. One of the key challenges with lithium-ion batteries is their cost. The price of lithium has been rising steadily, primarily because it is relatively scarce. The supply of lithium is concentrated in just a few regions, mainly in countries like Chile, Australia, and China. This has led to supply chain issues, making it difficult to meet the growing demand for lithium-ion batteries. As the electric vehicle (EV) market continues to expand, the need for lithium is only increasing, exacerbating the cost problem. In addition to the financial concerns, lithium-ion batteries are not without their safety risks. Lithium batteries are known to be prone to fires and explosions due to the formation of dendrites. These are tiny needle-like structures that can form inside the battery during charging. When these dendrites puncture the separator inside the battery, it can lead to a short circuit, resulting in a fire or even an explosion. This is a serious safety concern, especially in electric vehicles, where the potential for fire is heightened by the large amount of stored energy. In fact, there have been numerous incidents where lithium-ion batteries in electric vehicles have caught fire, drawing attention to the risks involved in their widespread use. Another issue with lithium-ion batteries is their limited lifespan. Over time, these batteries degrade as they go through charge and discharge cycles. After about 2,000 cycles, lithium batteries start to lose their capacity, and their performance diminishes significantly. For consumers and manufacturers alike, this means that battery replacements are necessary within a few years of use, adding to the total cost of ownership of electric vehicles and other devices. Despite these limitations, lithium has remained the dominant energy source, largely because there has been no viable alternative. That was until recently, when Tesla, known for pushing the boundaries of technology, began developing a new kind of battery that could change the landscape of energy storage forever. Tesla's new battery is an aluminum-ion battery, a revolutionary technology that promises to not only address the shortcomings of lithium-ion batteries, but to completely overshadow them. At the heart of this shift is one simple fact: aluminum ions are far more efficient than lithium ions. While lithium ions carry only one positive charge, aluminum ions carry 3. This means that aluminum can move 3 times more energy per ion, significantly boosting the energy density of the battery. Unlike lithium-ion batteries, which require complex and expensive materials, the aluminum-ion battery relies on more abundant and cheaper resources. Aluminum is the third most abundant element on Earth, making it far more accessible than lithium. It is also much easier to refine, reducing both the environmental and economic costs of production. Moreover, Aluminum-ion batteries do not use cobalt, a critical component of many lithium-ion batteries. Cobalt mining has been linked to numerous ethical and environmental issues, particularly in countries with poor working conditions and unstable political environments. The absence of cobalt in aluminum-ion batteries makes them a more sustainable and ethical choice, addressing some of the most pressing concerns about lithium-ion technology. In addition to being more affordable and abundant, aluminum-ion batteries are far safer than their lithium counterparts. As mentioned earlier, one of the biggest risks associated with lithium-ion batteries is the formation of dendrites, which can cause fires and explosions. Aluminum-ion batteries do not form dendrites, making them far less likely to catch fire or explode. This drastically reduces the need for costly cooling systems and safety mechanisms that are necessary for lithium-ion batteries. Moreover, aluminum-ion batteries can operate in a wider temperature range than lithium batteries. Lithium-ion batteries typically operate safely between 0 degrees Celsius and 45 degrees Celsius, and any significant deviation from this range can lead to performance issues or even safety risks. Aluminum-ion batteries, on the other hand, are stable from 40 degrees Celsius to 85 degrees Celsius, far beyond the safe operating range of lithium batteries. This increased stability makes aluminum-ion batteries a more reliable option for a variety of applications, including electric vehicles, where temperature control is crucial. The supply issue, which has been a major problem for lithium-ion batteries, is also addressed by aluminum-ion technology. While lithium reserves are concentrated in just a few countries, aluminum is available almost everywhere and can be easily mined and refined. This decentralization of supply means that aluminum-ion batteries are less vulnerable to geopolitical tensions or disruptions in the supply chain. The widespread availability of aluminum also makes the battery more cost-effective, as it eliminates the need for expensive and rare materials that are often required in lithium-ion batteries. Tesla's aluminum-ion battery technology is more than just an alternative to lithium. It represents a complete overhaul of how we think about energy storage. It addresses the issues of cost, safety, lifespan, and supply chain instability that have plagued lithium-ion batteries for years. But the benefits don't stop there. Aluminum-ion batteries don't just compete with lithium, they completely outclass it. The difference is not incremental, it's revolutionary. The most striking feature of aluminum-ion technology is its energy density. Lithium-ion batteries, despite their widespread use, have limitations in terms of how much energy they can store. The best lithium-ion batteries can store up to around 250 watt-hours per kilogram. This is sufficient for many applications, but it has its drawbacks, particularly when it comes to electric vehicles. For instance, a typical electric vehicle powered by lithium-ion batteries can travel around 300 miles on a single charge, depending on the size of the battery pack and the efficiency of the vehicle. Tesla's aluminum-ion batteries, however, are a game changer. They can store over 5,000 watt-hours per kilogram. This is an enormous leap forward, and the implications are profound. In practical terms, this means that an electric vehicle equipped with aluminum-ion batteries could see its range increase dramatically. A Tesla Model 2, for example, could potentially travel from around 330 miles to over 3,000 miles on a single charge. An order of magnitude increase that would eliminate the range anxiety many consumers experience today. This shift could make electric vehicles far more convenient, appealing, and practical for a wider range of drivers. This drastic improvement in energy density is made possible by the unique properties of aluminum ions. As previously mentioned, aluminum ions carry 3 positive charges, while lithium ions only carry 1. This means that aluminum batteries can carry 3 times the energy per ion, compared to lithium-ion batteries. The result is an energy storage solution that not only holds more power, but does so more efficiently. which is crucial for applications like electric vehicles that rely on lightweight and compact energy storage systems. Another crucial area where aluminum-ion energies leave lithium-ion batteries behind is lifespan. Lithium-ion energies, despite their initial promise, have a relatively short lifespan. On average, a lithium-ion energies of of energy atoms solved before it starts to degrade significantly. After these cycles, the battery's capacity diminishes, meaning that it holds less energy and provides shorter ranges or less reliable performance. This degradation is a major concern for consumers and manufacturers, as it leads to the need for frequent battery replacements. On the other hand, aluminum-ion energies offer an astonishingly long lifespan. These batteries can last over 50,000 charge cycles, which is enough for around 70 years of daily use. This is possible because aluminum-ion energies feature self-healing electrodes. Over time, micro cracks can form in the electrodes of a battery, which in lithium-ion energies leads to loss of capacity and eventual failure. Aluminum-ion energies, however, can repair these cracks automatically, ensuring that the battery maintains its performance over time. This makes aluminum-ion energies not only longer lasting, but also more cost-effective in the long run, as consumers will not need to replace their batteries as frequently. One of the biggest frustrations with lithium-ion energies is their charging time. A typical lithium-ion battery can take up to an hour to charge to 80%, and several more hours to reach a full charge. This is not ideal for consumers who rely on their electric vehicles for daily transportation and need to quickly charge their cars while on the go. Aluminum-ion batteries, however, are capable of charging much faster. These batteries can reach a full charge in just 10 minutes, which is a dramatic improvement. This is possible because aluminum ions move 3 times faster than lithium ions, allowing the battery to charge quickly without experiencing the same heat buildup or safety issues that plague lithium-ion technology. This improved charging speed could be a game changer for the electric vehicle industry, making long charging times a thing of the past. Safety is another critical issue where aluminum-ion batteries outperform their lithium counterparts. Lithium-ion batteries are notoriously prone to fires and explosions, especially when they are damaged or improperly charged. This is primarily due to the formation of dendrites inside the battery, which can lead to short circuits and thermal runaway. In contrast, aluminum-ion batteries are inherently much safer. They do not form dendrites, eliminating the risk of fires or explosions. Additionally, aluminum-ion batteries can operate in a much wider temperature range than lithium-ion batteries. While lithium-ion batteries typically operate safely between 0 degrees Celsius and 45 degrees Celsius, aluminum-ion batteries can function stably between 40 degrees Celsius and 85 degrees Celsius, far beyond the safe operating range of lithium-ion batteries. This makes aluminum-ion batteries a safer and more reliable option for a wide variety of applications, including electric vehicles, which are particularly sensitive to temperature changes. One of the most significant challenges faced by the electric vehicle industry is the environmental impact of battery production. The extraction and refining of lithium, cobalt, and other rare earth materials for use in lithium-ion batteries can have a significant environmental toll. Mining for these materials often involves environmentally destructive practices, including habitat destruction and water pollution. Additionally, the transportation of these materials contributes to carbon emissions, further exacerbating the environmental footprint of electric vehicles. Aluminum, however, is the third most abundant element on Earth and is much more easily sourced and refined. This makes aluminum-ion batteries not only more sustainable, but also more ethical, as they avoid the use of conflict minerals like cobalt. By using aluminum instead of lithium or cobalt, aluminum-ion batteries could reduce the environmental and ethical concerns associated with the current battery technology. Another important aspect of aluminum-ion batteries is their recyclability. Lithium-ion batteries are notoriously difficult to recycle, and the recycling process itself is often inefficient, with much of the material being lost or degraded. In contrast, Aluminum-ion batteries retain up to 95% of their efficiency even after multiple recycling cycles. This is a huge advantage from both an economic and environmental perspective, as it reduces the long-term production costs and waste associated with battery production. The ability to recycle aluminum-ion batteries more effectively means that less raw material needs to be extracted, and fewer batteries end up in landfills, contributing to a more sustainable and circular economy. The benefits of aluminum-ion batteries go beyond just the technical aspects. These batteries could fundamentally change the economics of electric vehicles, making them more affordable for the mass market. Lithium-ion batteries are expensive, and this high cost is one of the main reasons why electric vehicles have traditionally been so expensive. Aluminum-ion batteries, however, could dramatically reduce the cost of battery packs. For example, a 50 kilowatt-hour battery pack that would typically cost around $7,500 with lithium-ion technology could be built for as little as $2,000 to $4,000 using aluminum-ion batteries. This reduction in cost could lower the overall price of electric vehicles by as much as 20%, making them much more accessible to a broader range of consumers. This affordability is key to accelerating the adoption of electric vehicles and making them truly mainstream. Tesla's upcoming Model 2, which is rumored to be priced under $15,000, could be powered by aluminum-ion batteries, making it not only cheaper, but also more reliable and longer lasting than any electric vehicle in its class. The lower cost of the battery could also lead to reduced maintenance and replacement costs, further enhancing the appeal of electric vehicles as a viable long-term investment. The exclusive features of aluminum-ion batteries are far beyond anything that lithium-ion technology could ever achieve. While lithium-ion batteries have served as the go-to power source for electric vehicles and mobile devices for many, the advancements presented by aluminum-ion batteries are set to redefine what is possible in energy storage. These new capabilities go beyond incremental improvements. They introduce entirely new possibilities for how we store and use energy. One of the most remarkable features of aluminum-ion batteries is their self-healing electrode system. In traditional lithium-ion batteries, micro-cracks naturally form in the electrodes over time due to the constant stress of charging and discharging. These cracks not only degrade the battery's capacity, but also make it more likely to fail after a few years of use. This is one of the primary reasons why lithium-ion batteries wear out and need to be replaced every few years. However, in aluminum-ion batteries, these micro-cracks are repaired automatically. Research has shown that these repairs restore up to 99.7% of the battery's original structure, ensuring that the battery remains as effective as when it was first manufactured. This self-healing property not only extends the lifespan of the battery, but it also improves its performance over time. In some cases, the repairs even improve the battery's efficiency by creating more efficient ion pathways, which means the battery not only recovers but actually becomes stronger. This technology addresses one of the biggest limitations of current battery technology and could revolutionize how we approach long-term energy storage. Another breakthrough made possible by aluminum-ion batteries is their ability to act as a true mobile power source. A single aluminum-ion Tesla battery pack could store up to 2,000 kilowatt-hours of energy. To put this into perspective, that is enough energy to power several homes for a considerable period, or to operate large industrial equipment. This makes aluminum-ion batteries more than just a power source for electric vehicles. They are essentially a portable energy station. For instance, Tesla's vehicles could be used to power homes, or even entire work sites during power outages or emergencies. This is made possible by Tesla's innovative survival mode system, which intelligently distributes energy during blackouts, ensuring that essential systems remain functional for weeks. This feature is especially important in regions prone to power outages or in disaster zones where access to reliable power is often limited. The ability to use an electric vehicle as a backup power source could significantly change how we think about energy distribution and resilience, especially in areas where infrastructure is fragile. One of the most astonishing aspects of aluminum-ion batteries is their deep sleep mode. Unlike lithium-ion batteries, which degrade when left in storage for extended periods, aluminum-ion batteries enter a crystalline-like state during periods of inactivity. In this state, the battery retains almost all of its capacity, even after 10 years of being stored. When the battery is needed again, it can be reawakened in just 30 seconds, fully ready to perform at its best. This capability makes aluminum-ion batteries highly reliable, even when they are not in constant use. For instance, in applications where energy storage is not needed on a daily basis, such as backup systems or remote energy storage, aluminum-ion batteries can be stored for long periods without the risk of degradation. This makes them ideal for applications where reliability and longevity are key. The improvements in energy storage and reliability offered by aluminum-ion technology are only part of the story. The impact of this technology extends far beyond just electric vehicle or mobile devices. In fact, aluminum-ion batteries have the potential to revolutionize the entire energy landscape, changing the way we generate, store, and distribute power. One of the most significant changes that aluminum-ion technology brings is the democratization of energy. Unlike lithium, which is primarily mined in a few locations and subject to geopolitical tensions, aluminum is abundant and widely available. It is the third most abundant element on Earth, and it can be easily mined and refined. This widespread availability means that aluminum-ion batteries are not reliant on scarce resources, and they can be produced more cheaply and efficiently than lithium-ion batteries. This could make clean energy technology more accessible and affordable, especially for developing nations that have limited access to traditional energy sources. In addition to being cheaper to produce, aluminum-ion batteries are also more environmentally friendly than their lithium-ion counterparts. The mining of lithium, cobalt, and other materials used in lithium-ion batteries often involves environmentally destructive practices, including habitat destruction, water pollution, and excessive carbon emissions. These practices not only harm the environment, but also raise ethical concerns, particularly in regions where workers are subjected to unsafe working conditions and exploitation. Aluminum, however, is more easily sourced, refined, and recycled. It also eliminates the need for cobalt, which is one of the most controversial materials used in batteries today. The removal of cobalt from the equation reduces the environmental and social impact associated with battery production. Furthermore, aluminum-ion batteries can be recycled much more effectively than lithium-ion batteries, with up to 95% of their efficiency retained after multiple cycles of recycling. This makes aluminum-ion batteries a more sustainable and ethical alternative to lithium-ion technology, aligning with the global push towards reducing waste and carbon emissions. The economic impact of aluminum-ion batteries is also significant. Electric vehicles, once considered too expensive for the average consumer, could become more affordable with the widespread use of aluminum-ion batteries. The cost of a 50 kilowatt-hour lithium-ion battery pack can reach up to $7,500. However, with aluminum-ion technology, that same battery pack could be produced for as little as $2,000 to $4,000. This reduction in cost could make electric vehicles much more accessible to consumers, accelerating the transition to cleaner transportation. In addition, the durability and longevity of aluminum-ion batteries mean that consumers will not have to replace their batteries as frequently, further reducing the long-term cost of ownership. The impact of aluminum-ion batteries on the electric vehicle industry cannot be overstated. The upcoming Tesla Model 2, which is expected to be powered by aluminum-ion batteries, is predicted to be priced under $15,000. This price point, combined with the battery's superior range, charging speed, and safety, makes it an attractive option for a wide range of consumers. The Model 2 could offer a range of over 400 miles on a single charge, with a full recharge in under 15 minutes, and it would last for decades without the need for replacement. This affordability, combined with the advanced capabilities of aluminum-ion batteries, could make electric vehicles more appealing and accessible to the masses, accelerating the global shift towards electric transportation. The widespread adoption of aluminum-ion batteries will also have far-reaching effects beyond the electric vehicle industry. They could transform how we power our homes, industries, and even entire regions. With their ability to store large amounts of energy, charge quickly, and last for decades, aluminum-ion batteries could serve as a backbone for renewable energy systems, allowing for more efficient storage and distribution of solar, wind, and other clean energy sources. In areas with unreliable power grids, aluminum-ion batteries could provide a reliable backup source of energy, improving the quality of life for millions of people around the world.